If it does not crash, then it's my computer issue. And so then I have to change out computers and try and crash that one again. So yeah, it's gonna be kind of cool. So it's neat when it's your job to break stuff. Anyway, all right, so we're kind of going over yesterday's thing, because yesterday we did some of the notes, but computer issues. So let's go ahead and talk about this again. So revolving light located 5 kilometers from a straight shoreline. Here's my shoreline. Okay, 5 kilometers. Here's my light. So this is my lighthouse, or light thingy or whatnot. Okay, located 5 kilometers from a straight shoreline. Turns at a constant angular speed. So it's a speed, it's an angular speed, so that's going to be a d theta. dt is going to be 3 rad per minute. 5 kilometers is going to be the distance from the shore to this light. With what speed is a spot of light moving along the shore when the beam makes an angle of 60 degrees with the shoreline? Now, when I was going over this yesterday, someone pointed out that I screwed up, so thank you. Okay, so on this one right here, this is my 60 degrees because it says shoreline. So this is my 60 degrees right here. So right there it's going to be 60, so that means down over here, this one's going to be 30 degrees. And because this is a straight shoreline, and we always measure the distance directly, we don't actually, have like a lateral distance. We just go directly from one place to the other, straight as the, what's the phrase, as a bird crow flies or something like that? As a bird flies. Crow flies. Something like that. No? Okay. You guys don't have any like old people that like try to impart wisdom on you all the time? And you hear like these strange idioms?
We don't like talking to boomers.
Because you get triggered by the boomer all the time, so don't even start. Anyway, all right. So, okay, with what speed is a spot of light moving along the shore when the beam makes an angle of 6 degrees with the shoreline? So, I have a lot of information right here. A lot of information, so we're looking for, okay, speed the spot of light is moving along the shore. So, in this case, I'm going to move it along the shore this way. Yes?
If the light were to go backwards, like in the opposite direction, would it still be the same?
Yeah, it'll still be the same thing because we're finding it at that specific point. Okay, at that specific point. So if I were to say it in the terms of like if it was growing or increasing or something like that. But this is just going to be a rate at that specific point. So I don't know, because of how this problem is set up, either way, it's just at that specific point. It's going in some direction. I don't know which one, but you know what? The reason why I set it like this and the reason why I chose it like this is this right here. 3 rad. So radian, so think of your unit circle. Which way did the unit circle go? It goes counterclockwise, doesn't it? Counterclockwise, and so that's why I went with counterclockwise on this. So that's the whole reason why I set that up. If you did it the other way, it'd still be the same. All right, so let's go through and find a couple things. So I know that I'm gonna find. What am I finding here on this one? Okay, so this one. So let's. I'm gonna go in and find. Put in a couple more values. Let's see, blue right here. So I'm gonna put in a couple more values. So this is going to be my x value. This one's going to be my y value. Yes?
Yeah.
Okay, good. X value and Y value. So, in this case, since I'm looking for the rate that it is moving, the X is moving, right? I know I'm going to need an X value, and I'm also going to need a dx d theta. Dx and d theta. So I'm going to need those. Now, is the Y value moving at all? No. Y value is not moving at all, right? So since the Y value is not moving at all, I am not going to have a rate of change for the Y value. No rate of change for that one. That one's going to stay constant. So Y value is always going to be 5 kilometers. Now, I have this. Now, I also have my speed that my angle is changing is 3 rad, so that's 3 radian per minute. So I have this one right here, which is 30 degrees, and degrees has to be converted into radian. So I will do 30 degrees over 1 times pi over 180. You know, that's the method to actually change one into the other. Yes, right? Okay. So change one to the other. So I do a little reduction, and I'm going to end up with pi over 6 as my angle. Now, let's see what we have here. Since we have a trigonomic thing, so since I am dealing with an angle, right? I'm dealing with an angle. So from this angle, this is going to be my reference angle right here. So from the reference angle, the x would be my opposite, and the y would be my adjacent. So opposite over adjacent is going to be my tangent, right? So I'm going to have tangent of my angle, which is in this case theta, is equal to x over y. X over y. Like I said, I'm going through and trying to solve a bunch of stuff. So, since I know that I do not have a rate of change for the y value, I plug that in. But I am going to have rates of change for my angle, right? I'm going to have a rate of change for my angle, and I'm also going to have a rate of change for my x value. So, by seeing what I have, eliminating what I don't need because those are constant, they're not changing, I'm going to plug in now, then do my derivative. Plug in now before you do your derivative, otherwise you're going to have a dy dt, and I don't want that. So, let's go ahead, and it's going to be 5, right? So tangent, oh, come on now. Okay, so tangent theta is equal to x over 5. Take the derivative of tangent, which is going to be my secant squared theta. So secant squared theta. And what else am I missing there? What?
D theta.
Yeah, d theta dt, right? D theta dt, because that's my change. D theta dt, that's my change in theta over time, is equal to, now, the derivative of x is just going to be 1, right? Okay, so it's going to be 1 over 5. So 1 over 5. And if I took a derivative of x, therefore I need to have dx dt. Now, I'm looking for, okay, with what speed is the spot of light moving along the shore? Okay, so I'm looking for my dx dt here. So my dx dt, I'm going to plug in everything but dx dt, because I don't have that one. That's the one I'm going to look for. So secant squared. So secant at theta, we said theta is pi over 6. Again, unit circle, pi over 6. So pi over 6 is just up a little bit from my line. So that means that the secant is going to be 1 over cosine. So secant is equal to 1 over cosine. So it's going to be 1 over cosine squared theta. And I'm going to take that. So at cosine of secant, it's going to be rad 3 over 2. But since this is a fraction over a fraction, I'm just going to do the reciprocal. Because secant is a reciprocal identity. It is a reciprocal identity. So I'm just going to flip over my rad 3 over 2. So it's going to be 2 over rad 3 squared times my d theta dt. So I'm gonna change up my colors. So we're doing it again, so it's gonna be 2 over rad 3 squared times 3 equals 1/5 and dx dt. So on the left hand side, I'm going to get 4 over 3. 4 over 3 times 3 is going to give me 4, right? And then multiply both sides by 5. Okay, so my dx dt is equal to 20, and my rate is going to be in kilometers. So it's km per minute. Kilometers per minute.
So did you just skip the step of finding what x is?
Do I need x?
I guess not.
Because when I took a derivative here, I did it yesterday. But like I said, I didn't have my notes to actually go back and check. So I was actually going through and finding everything on that one. So like I said, yeah.
Alright.
So it wasn't necessary, but I could also find it, right? So you could find out what x is. So if we did that, so we know tangent, here, I'll do it. So we say tangent of pi over 6 is equal to, was it x over 5, right? So it's going to be 5 tangent at pi over 6 is x. So tangent at pi over 6 was sine of a cosine, so it's 1/2 divided by rad 3 over 2 times my 5 is equal to the x. Multiply by reciprocal, so I'm going to get 5 times 1/2 times 2 over rad 3. Yes? Okay, so I'm multiplying by reciprocal, 2's will cancel, so I'm left with 5 over rad 3. Rationalize is going to give me 5 rad 3 over 3. So when I do this right here, that is going to be my value for x. But if you recall, I actually don't need x on this one. I don't need x. If I had x, it'd be fine. Okay? But still, it wasn't necessary in the end result. So 20 kilometers per minute that's how it's going to travel. Okay? So let's take a look at, all right, before I go on, questions here? You still good? Okay. So, next one. Okay, for motion that is circular, angular speed W, so this is super important. This is like one of those trigonometry things you guys have to know. So highlight, underline, copy this down and, tattoo it to the back of the hand. All right, angular speed, or what's that other stuff you said to use instead? Yes. Instead of tattooing it, you said?
Him now.
Yeah, there we go. I can never say it right.
Why not?
I don't know, because,
Try it.
no,
Yes.
no.
Say it.
'Cause- no, I can say it now that you said it, but now if I try and say it, I might say something other that sounds ridiculous. So anyway. All right, as defined as the rate of change of the central angle, okay, angular speed, W, okay, that is a rate of change. So if it says it's an angular speed, that is already a rate of change. So that's always going to be a d theta dt. Okay, that's super important for later because that is going to be one of the questions. All right, I think that's it. Like, share, and subscribe. Let's see if I actually made it through a whole video. So, must be my computer then.